Hello friends, I hope that you all are keeping well. So in this screencast, I'm going to talk about the pre-release solution for the Cambridge International Examinations, June 2022, paper number 0478 and the component 22. As you know that this pre-release is based on the booking of tickets for a WildLife, where a number of scenarios have been given. And the students are expected to take the number of adults, seniors and children as an input and then calculate the best possible price for the tickets. Honestly speaking, when I saw this pre-release document first time, I felt that this is a very simple scenario given and the students will be able to solve it quite easily. And one thing more I noticed about this particular pre-release scenario is that here the focus was not mainly on the use of arrays, but a lot of decision-making statements. And I really thought that by writing a couple of decision-making statements, the students will be able to find out the cost of ticket for each of the bookings. However, when we started discussing about this scenario in the classroom, and especially when we looked at the requirements for the task 3, that really, made us realize that this pre-release was not as simple as we initially thought about. It's obviously not difficult if each of these categories are to be dealt separately. So we can write a couple of decision-making statements under LF ladder. And the system would go to the most appropriate condition and calculate the ticket cost. But there's a catch, and the catch is that the students need to look for different permutations and combinations and then finally decide that which of the options would give them the cheapest cost for the ticket. So before we jump onto the solution, first let's look at the complexity of the problem. So as you can see here in this table, there are different ticket types given. For example, if there's an adult who is willing to buy a ticket, he or she has to pay $20 for 1 day and $30 for 2 days. If there are children, they are charged at the rate of $12 and $18 respectively, but there's a condition that one adult can bring maximum up to 2 children, which means that if there's an adult with 3 children, then those children are not going to get tickets at the rate of $12. Rather, the only way one adult and 3 children could be booked under would be under a family ticket. So under a family ticket, up to 2 adults or seniors and 3 children collectively have to pay $60. And then there is a 5th category, which is a group ticket. So if there are 6 people or more, they are eligible to buy group tickets. Now, when I first looked at this pre-release scenario, I thought that there would be a couple of conditions and the students would be able to easily solve it. But when we started discussing the scenario with the students, we realized that the solution was much more difficult than what we initially thought. And to understand that complexity, as you can see in task 3, it says that the students are expected to not only calculate the ticket cost, but they also have to ensure that the cost of the ticket should be the cheapest option by making different permutations and combinations. For example, they have given an example here that buying 2 family tickets is better than a group ticket for a group of 10 that includes 4 adults and 6 children. So look at this example. So they say that there are 4 adults and 6 children. Now, one easiest way would be to make a group of this. So $90 and calculate 4 adults times 20, which is 80. So 80 plus 90 would be 170. However, if we look at it from another perspective, so we can say that 2 adults plus 3 children and 2 adults plus 3 children, 1 family, second family, which makes it a total of 120, which is definitely much lower than getting one group and 4 independent adults. Let's take one more scenario where we have 2 adults, 2 senior, and 3 children. Now in this case, as we can see that a family could be created because we have 2 adults, 2 senior, and 3 children. And according to this scenario here, a family ticket can be up to 2 adults or seniors and 3 children. So we could either create a family between these two, or we can create a family between adult and children. But here we have to be careful, because if we take 2 adults plus 3 children, this would be 60, and we are left with 2 seniors. So 2 seniors would be 16 times 2, that is 32. So the cost is 92. Whereas if we take if we make a family of senior and children, that would mean that 2 senior plus 3 children equal to 60, and we are left with 2 adults. So 2 adults would be 40, which is 100. So in this case, this is the better option, and that is what we have to propose to the customer. So the main requirement to solve this pre-release successfully is to be able to divide the number of people into sufficient number of groups, families, and then the leftovers, which could be individual adults, individual children, and individual seniors. So let me first show you the program. So this is not the actual program. This I have written just to calculate the best possibilities in order to divide the numbers into number of groups and families, etc. So first I will show you the working of this program, and then I will show you the actual program where all other inputs, for example the extra attractions and other things, have been taken. So let's use this program to first test a few scenarios. So let's take up any random numbers. So let me take 1 adult, 3 seniors, and 5 children. So before we expect the system to do the calculation, let's first do a calculation ourselves to see that what would be the best possible combination. So 1, 3, and 5. So let me remove all this. So we have 1 adult, 3 seniors, and 5 children. Okay, so let's look at the possibilities. Maybe we can take 2 seniors plus 3 children to make it one family. So now we are left with 1 senior and 2 children and 1 adult. So what else can we do? So 1 adult can go with 2 children as per the scenario, as per the first condition which is given here. 1 adult may bring up to 2 children. So if we go by that rule, so 1 adult plus 2 children, right? So this is 60, this is 20 plus 32, 2 children means 16 times 2 is 32, plus 20 is 52. And now we are left with 1 senior, which is 16. So total cost would be 128. Okay, let's look at our program. So we have 1 family, 1 adult, 2 children, and 1 senior. Let's see if the program gives the same output. So if we see here, so total tickets requested is 9. There are no groups possible. 1 family, 1 adult, 1 senior, and 1 child. And that's what we can see over here. 1 family, 1 adult, 2 children, and 1 senior. Okay, let's see one more scenario. Adults 3, seniors 3, and children, let's take 5. So let's first work out. So we have 3 adults, 3 seniors, and 5 children. Okay, now let's have a look at the possibilities. One possibility could be that we take 3 plus 3, we make it one group, and even though it is one less, but this can also be taken as one group. So we have 3 adults plus 3 children, sorry, 3 seniors, that's $90, and then 5 children is also 90, which is 180. So this is one possibility. Second possibility could be that we try to make the family. So that means we can take maybe 2 adults plus 3 children, which is 60. So now we are left with 1 adult, 3 seniors, and 2 children. Now this total is 3 plus 2 plus 5 plus 1 is 6. So that means 6 people make one group, which is 90. So this one is 150. So since 150 is lower than this, so therefore the best ticketing possibility would be $150. So let's see what the program does. Okay, so alright, so one group, one family, and the same thing we got over here. So one family and one group. Friends, I've been working on the solution to this problem for quite some time, and I really find it quite challenging because there are so many different combinations which are possible in order to calculate the least possible ticket cost. Just now we saw a couple of examples, and these are just a very few possibilities. But if you actually start giving different number of adults, seniors, and children, you would see that those number of possibilities would increase exponentially. I've been trying to think about the logic of this program by taking into account different combinations of adults, seniors, and children. And believe me, I mean, the more I try, the more confusing it becomes, because there are so many possibilities to make out of number of adults, seniors, and children that it becomes sometimes so confusing that what I'm doing and which direction am I heading to. One thing that I have noticed by taking many examples, many cases, is that the first and foremost thing we should try to do is to find out the number of families that are possible in the given number of adults, seniors, and children. Because as you can see that for up to 5 people, the cost is $60, which is much lower than any other combination. And this is what I have used in my program. Although I'm not saying that this could only be the solution, but this is what I thought would help us to reduce the numbers to an extent that we will be able to bring down the number of adults, seniors, and children all less than 6. As it is given in the scenario that the family comprises of up to 2 adults or seniors and 3 children. So therefore, in my program, if you see, the maximum number of families which would be possible on the basis of adults and seniors would be total divided by 2. Total is adult plus senior. So that means if there are 10, let's say 5 adults and 5 seniors, that means total is 10. So maximum families possible would be 5. Whereas for the children, it is children divided by 3. For example, if there are 30 children, so the maximum families possible would be 10, right? However, if we take both into account, then the maximum number of families possible would be the one which is less in number. So let's say we have 10 total adults and seniors and 30 children. So in children, by taking children into account, we can make 10 families. But since we have only 10 adults plus seniors, so the maximum families would be 5. So in that case, the maximum families cannot be 10 because we don't have enough adults. Because if we make 10 families, we need 20 adults and seniors. But since we have only 10, so the maximum families possible would be 5. So when we are making 5 families, that means total 10 adults plus seniors and maximum 5 times 3, that is 15 children. That would make a total number of maximum families possible. And to see the relevance of family division, let's take a new case. So let's suppose we have 3 adults, 4 seniors and 7 children. So before we see the output of the computer program, let's go and do a calculation here. So we have 3 adults, 4 seniors and 7 children. Now one possibility could be that we can have a look at the possibility of a group. So what we can do is we can take out 6 from here. So we are left with 1 child. So 6 children would be $90. Okay, we still have 1 child left. Now we can take up 4 seniors plus 1 child plus 1 adult. So that means 4 senior plus 1 child plus 1 adult, which is again 90. And now we are left with 2 adults. So 2 adults would be 40. So total cost would be 180 plus 40, which is $220. So this is the scenario when we are not emphasizing on the family tickets. Now let's try to recalculate by looking at the possibility of taking few families. So what I'm going to do is let's take 2 senior plus 3 children, that is 60. Okay, so now we are left with 2 seniors and 4 children. Next we can do is again we take 2 seniors plus 3 children, which is again 60. So now we are left with, this is done, and here we are left with 1 child. So now we have 3 adults and 1 child. So this can definitely go as per second criteria, that 2 adults can take maximum 3 children. 2 adults can take maximum 4 children. So here we have 3 adults and 1 child. So 3 adults would be 60 at the rate of 20 and 1 child would be 12. So total cost here is 180 plus 12, that is 192. Now 192 is still better than 220, but is this the best price? Let's try few more possibilities. For example, let me clear this up. So the second possibility was 192. Let's work out something more. Now in the new scenario, let me take 2 adults plus 3 children, which is $60. So that means we are left with now 1 adult and 4 children. Okay, next scenario, we take 2 seniors plus 3 children, which is again 60, and we are left with 1 child and 2 seniors. Okay, which would mean that these prices can be calculated individually, because 1 adult, 1 child can go together. So 1 adult would be 20, 1 child would be 12, and 1 senior would be 16. So total would be 168. And you can see that if we compare these three, 168 is the cheapest option. And this is what makes this program very, very complex, in order to find out several permutations and combinations and then reach out to a conclusion where you can say for sure that this price is the lowest one. Now let's see what our so according to this, we have 2 families plus 1 adult plus 1 senior and 1 child. Let's see what output our program gives. So we have the same number of people. So we have no groups. We have 2 families, 1 adult, 2 seniors and 1 child. Okay, there are 2 seniors, so we need to check this, why it is 2 seniors. Oh yes, sorry. So we had 4 seniors, out of which we took 2 seniors for the family. So this is actually 2 seniors. And anyway, even if we add the cost of 16 more for the 1 remaining senior, that would make it 184, and 184 is still less than 192, and therefore this would be the correct distribution of numbers. So after we have created the number of families, we will have to reduce that many members from the actual number of adults and seniors. For example, let us say that we created 3 families. So if we have created 3 families, that means total 6 number of people will have to be reduced in between adults and seniors. And similarly, if we have 3 families, that means 3 times 3, 9 children we will have to reduce from the total given number of children. And that is the reason why we have taken the smaller possible family number between either adults and seniors or children, because it will give us the flexibility to reduce enough number of people. If we have more number of families than the actual number of adults and seniors, we cannot reduce the required number. So that's why we have first taken out how many maximum seniors families can be created, seniors plus adults, how many maximum families can be created from children, and whichever of the two is less, that is the maximum number of families possible. And you can see here that if there are families being created, okay, that means out of the given values we have a possibility of creating the families, then child equal to child minus family times 3. So if there are 3 families, we are reducing 9 children from the actual number of children, and similarly total equal to total minus family times 2. And then there are some calculations that in case if there is a family created, okay, where the total becomes 0 and the number of children still exist, okay, we cannot have a scenario like that. So let's take an example. For example, we have 2 adults, 0 seniors and 4 children. Now in this case you can see that since there is a family possible, and this part will actually create a family, it will create one family with 2 adults and 3 children, but the problem would be that one child will be left alone, and since the child is left alone, so it will turn out to be very expensive, because for one child we will have to pay $90 as a part of the group. So in this case we don't need to create a family. So even though the family was created here by the previous logic, what we are checking here is that if total becomes 0, and obviously it will become 0 because after making the family, one family, we will have to reduce adults by 2, so it becomes 0, and child is greater than 0, which is true because the child is 1 after removing 3 in the family. In that case we are again reducing family by 1, so family which was made 1 will now become 0, and children we have increased by 3 because the 3 children which were taken away in the previous family will be given back to child. Now this part is increasing the number of adults by 2. So this logic you will have to go through line by line in order to understand that why we have not just written adult equal to adult plus 2, rather we have done so much of calculation. That has a logical reasoning, and if you go through the each line, you will understand why we are doing that. So when we run this, you will see that the output would be group 0, family 0, adults remains 2, and child remains 4. And once we have determined the number of families, then we next requirement would be to identify number of groups possible, and that's why you can see here that we are out of, and we start that with the children, because our objective would be to first reduce the number of children. Okay, once the children have been reduced, the next possibility we have to see is that reduce the number of adults, and finally reduce the number of seniors. So if you have to make a choice between adult and senior, we would prefer reducing adults as compared to seniors, because the cost of adults is $20 and the cost per senior is $16. So first reduce the child, then reduce the adults, and finally reduce the seniors. And if you go through the logic what we have used here, you will understand that why so many lines are written under each section. And once we are on line number 83, we can be sure about one thing, that all 3 members, that is adults, seniors and children, would be reduced to the bare minimum possible, because we have already extracted enough number of families, we have already extracted enough number of groups. So what we will be left with would be the bare minimum value. So no matter what the values are, let's say 20 adults, 25 seniors, and 66 children. So you can see here that total 22 families have been created. There are no adults left. There is one senior, there is one child. So the idea is that by the time we reach to line number 83, the program should be able to reduce the numbers to bare minimum, ideally everything less than 6. So it will create number of groups, it will create number of families, and then what we will be left with is adults, seniors, and children which are less than or equal to 6. So try anything, like for example 100, 200, 700. So no matter how many values you give, you can see here the total groups created are 42, total families created 149, and then we are left with 2 adults, 0 seniors, and 1 child. And next part of the program is going to calculate for these individual combinations. It might look simple here that, oh, it's quite simple to calculate 2 adults, 0 seniors, and 1 child, but it's not as easy as it looks. And that's what has been done from line number 85 until the end. This is just to deal with the remaining ones. This all is to deal with the remaining possibilities. So finding the number of groups and families is not that difficult. What is more difficult is that when you have the numbers less than 6, then to make different possibilities to find out how you are going to deal with these numbers. So this is actually the shorter version of the program which I wrote to look at different possibilities in order to create number of families, groups, and leftover adults, senior, and children. The actual program is this one, which takes care of all 3 tasks which are given in the pre-release. And as you can see here that I have used the date library functions in order to read the current date from the system and then display the next 7 days, because it's given in the pre-release that we need to book where is it? Okay, it says here that it can be booked for the same days and can be made up to a week in advance. So for that we need to have the 7 days listed, which you can see here that I have done it using the date library function, which is here. So I've run a loop from 1 to 7, and with this function I have displayed different dates starting from 12th of February until the 18th of February. And then it asks the users to input the date. For example, the user inputs the date as 2, which means the starting date is 13th of February, and number of days, let's say I give 3. So since the maximum number of days possible permitted is 2, so I will have to give maximum 2 days. And then it asks number of adults, seniors, and the children. So let me give any value, let's say 3, 3, and 7. Okay, and then it will bring the previous program into picture, and it will calculate the best possible options. But before that we have to input the number of lion feeding tickets and 0 for none. So let's say I give 2 people for lion feeding, I give 3 for the penguin feeding, and I give 1 for the barbecue. So by taking all those inputs into consideration, you can see here that ticket number is 1, dates reserved is 14th and 15th, total days is 2. Attractions, lion feeding, there are 2, which is $10, $5 for each day because it's a 2-day booking. Penguin feeding 3 number, so $12. Evening barbecue 1, which is $10 for the 2 days. Now family tickets, now this is the calculation, this is the division which has been done by the program according to the given numbers. So family tickets 2, $180, adult ticket 1, $30, senior ticket 1, $24, children ticket 1, $18, and total cost is $284, which is the bare minimum which the person has to pay in order to book the ticket. And if you wish to continue, just say 1 and repeat. So it's asking for the date of booking. So let's some validation tests. For example, if I give 8 here, it wouldn't accept because it's asking for between 1 to 7. So let me take the last date, which is 7th. So when I give 7, it says number of days. If I give 2 days on the last day, it shouldn't accept because we don't have 2 days left on the last day. So it says for the 7th day, 2 days booking is not allowed. So number of days I give as 1. Now total number of adults, let's say 4. Total number of seniors 7. Total number of children 4. Any random values. Then it's asking for number of lion feeding, let's say 2. Number of penguin, let's say 0. Now it wouldn't ask for the barbecue because for barbecue the condition is that you need to have minimum 2 days of ticket booking. So in the program that validation has been given. So it will not even ask us for the barbecue, as you can see here. And once the inputs have been given, the summary of ticket is here. So this is ticket number 2 because the previous one was 1. Date reserved is 19th Feb, just for 1 day. Attractions, lion feeding is 2. We did not opt for penguin and barbecue wasn't asked. So attractions is only 1. Now it has done the calculations for 4 adults, 7 seniors and 4 children as 1 group booking, 1 family ticket, 1 total number of adults left are 2 and senior left is 1. So you can actually take these numbers into a paper and try to find out that how this distribution has been done. And accordingly for group ticket it's $90, 1 group, 1 family is $60, 2 adults is $40, 1 senior is $16 and 1 child is possible with 2 adults, so it is $12. And the total ticket cost is $223, which is bare minimum out of all given options. Now let's quickly have a look at the program. So it starts with the importing of date library files, and then we have printed the heading. So the heading which you see on the top, let me clean it up. So this heading is coming from here. Okay. And then although the arrays was not required, but just because the students have been learning about arrays, so I use it deliberately in order to store cost 1 day. This is the cost 1 day coming in from the pre-release over here, 20, 12, 16, 60 and 15. Similarly, cost of 2 days, that's another array, 30, 18, 24, 90, 22.50. The ticket number, the counter I'm using for the ticket numbers. So every time a new ticket is booked, the ticket number will be increased by 1. Now these are the extra attractions. I have stored those text fields, text values into the array for ease of printing. And then extra cost 2.50, 2 and 5, which are all taken from here. So one array is storing these details. One is storing the cost. One is storing the cost for 2 days. One is storing the extra attraction description, and one is storing the cost per person. So those are the arrays that I have used. Now this while loop is to repeat because the pre-release says that keep repeating until the user wants, as you can see here. Somewhere it says that keep repeating. Repeat as required. So to take care of this, a while loop has been used, which puts the entire program into the loop. Now here we are printing the, you can see here print ticket type I. So ticket type is this 1 adult, 1 child, 1 senior, family ticket, group person. So this text is coming through that loop. Next is cost 1 day I. So cost 1 day I is printing 20, 12, 16, 60 and 15, and third value getting printed is cost 2 days. So this first table which you see here in the output is coming from this loop. After that we are printing the next loop, which is extra attractions. So heading is extra attractions and cost per person, that's the heading, and then we are running a loop 3 times to print lion feeding 2.5, penguin feeding 2.0 and evening barbecue 5. Okay, then comes task 1, show the days available for booking. Assume that there are tickets available for only valid days, and for doing that select the date of booking 1 to 7, that's the heading coming here, and then these dates are coming from this loop. Actually, there's a mistake. This should have been 1 and then this should be 2. So let me quickly correct this. So this loop should be print I plus 1. Okay, so now it should be okay. Yeah, so 1 2 3 4 5 6. So first date, you can see here that the first date we have printed manually. So 1 begin date, this is coming manually, and then rest of the dates we are getting from the loop, and this is the function begin date string plus time delta days equal to I. So what this function does is, whatever is the current date, it will add 1 2 3 4 5 in order to get the remaining dates. And then date choice we have taken, as long as it is less than 1 or greater than 7, it will keep on repeating. So that's the validation. So once all this is done, then so these are the validations which I showed you, that if it is a 7th day, then 2 days booking is not possible. These are all self-explanatory, so you can just go through this. And once this all is done, then we are asking for the number of adults, seniors and children. And this is for the lion feeding, penguin feeding and evening barbecue. And we have taken it -1 just to make this loop true initially, so that at least it should enter for once. This is again self-explanatory, so if you go through the code, you will understand easily why we are doing this. Okay, this I had taken some temporary values for adults, seniors and child, but this doesn't matter, so I can just remove this. Actually, this wasn't used in the program. Okay, now family equal to 0. So this is where we start the program which we saw in the previous section. So in this section we saw this entire code, so that is coming over here. So this entire thing is to find out number of families, number of groups. You can say group equal to 0, and then we calculated the groups, and then we found out the remaining adults, children and seniors, and to get the best possibility from that. And this all is about finding the best permutation and combination for remaining children, seniors and adults. So this all we already saw in the previous program. And once we have calculated that, after the line number 217, we will have total number of groups, total number of families, total number of adults left, total number of children left, and total number of seniors left. And that is what we are going to use in order to calculate the total price. So you can see here that we have said, so let's run the program. So it's enter number of date of booking. So I say 1, and for 2 days, total adults 2 3 6, total members is 11. Number of lion feeding, let's say I don't want. Number of penguin feeding, I want 2. Number of barbecue, let's say I take 2. Okay, now how this is getting calculated? So once we have given those inputs, then summary of tickets, which is here. Ticket number 1, because we are running the program for the first time now. Ticket number is printed. Dates reserved, so it's coming, it's showing here dates reserved, which is the 2 dates that we have chosen. Total number of days is 2. Then it shows the attractions. So I have taken 3 variables: lion feeding cost, penguin feeding cost, and evening barbecue cost. If the user has chosen lion feeding, then the lion feeding charges have been calculated. Okay, if they have chosen 0, then this part will be ignored. And if this part has been chosen, then we are simultaneously also totaling the total cost. So if there is some cost towards lion feeding, we have accumulated that into total cost. And then we have printed lion feeding, how many members for lion feeding, and what is the total cost for lion feeding. So that amount is coming over here. You can see that we did not choose lion feeding, but we have chosen penguin feeding. So penguin feeding, total number of tickets 2, and total cost is $8, which is coming from here. And this amount will be added to the total cost. So total cost was 0 here because no lion feeding, but total cost will become 8 here because there is penguin feeding. Next, similarly, we are also calculating the evening barbecue, but since we did not have, so nothing will happen to total cost. So from this part, the total cost will be the total of extra attractions. But we will continue this even further. Now here we have group cost 0, family cost 0. So this we have assigned 0 to all the variables. Okay. Now we have two possibilities, either 1 day or 2 days. Okay. So it's the same code. The only difference is in the use of array names. So if it is 1 day, I've used cost 1 day array, and if it is 2 days, then I've used cost 2 days array. Otherwise everything is same. Now you can see here that now since we have the number of groups and everything available, so we are checking that if group is greater than 0, that means if there has been a group calculated by the system, then calculate group total number of groups which the system has calculated based on the number of people times cost 1 day 4. Why 4? Because on the fourth location, on the fifth location of the array, we have taken the cost of each group member, which is 15. Okay, you can go up and see that on the fifth location of cost 1 day, we have 15. So 15 times 6, which is 90, times number of group, that will give us the total group cost. And then we have printed group tickets, how many groups are created and what is the total group cost, and then we have added this to the total cost. So total cost is something which is ongoing. With every new cost added, it will keep on accumulating into the total cost. So group is done. Now we are checking if family is greater than 0. Then family cost equal to family, number of families, times cost 1 day and the fourth location in the single dimensional array. So it will calculate total family cost, and that will be printed, and that will also be accumulated into total cost. So once the group and family are done, then we may have some leftover adults. So if there are any adults left, then that is at the cost of $20 for 1 day, which is there on the 0th cell of that cost 1 day. So number of adults times $20. Then we have printed adults and accumulated that value. Same for seniors, same for children. And if the number of days is 2, then the control will come to this part, and it will just, everything is same, just that cost of 2 days will be taken from the next array, which is defined up. Okay, so it will calculate the cost for 1 day or 2 day for each of the components, and finally we have printed the total cost, and then we have asked the user to repeat, and that's the end of the program. So let's try one more. So I give the choice as 1 to repeat. So it's asking me the date of booking, so I give 5. 5 is 16th Feb. Okay, so number of days, let's say I give 2. Number of adults, let's say 90s. Oops. Number of seniors 60. Number of children 88. Because there is no limit, we can take any number of people, and the system should be using different logics to find out the number of groups, the number of adults, the number of children, senior and families. Okay, so number of lion feeding tickets, let's say I give 36. Number of penguin feeding 25. Number of barbecue 60. Okay, and based on these values you can see that there are numbers. There's little problem with the formatting, which I will correct it, but anyway it's good enough to understand. So lion feeding we have 36 numbers, which is $180. Penguin feeding 25, which is $100. Evening barbecue 60, which is $600. Group tickets is 15. The system has calculated 15 group tickets out of the given number, so which makes it $2025. Family tickets, it has come out with 29, so it's 2610. Adult tickets left are 2, so that's $60. Why 60? Because it's for 2 days. Children ticket 1, which is $18 for 2 days, and total cost is $5593. And that brings us to the end of this screencast. So I hope that you will be able to find the solution good and useful. Although I am not still very sure that all the permutations and combinations have been taken care of, and if I find anything new, I will just keep on adding more and more conditions, but this is what comes to my knowledge, to the best of my ability. I will be putting this code into the description of YouTube, so feel free to use it from there and make changes as per your requirement. Thank you so very much for your time, and enjoy working on this pre-release. Bye everyone.